what's going on, everyone? We're back. I think this is episode 11 now, Underscope Podcast. Today, I'm joined by Dr. Hongwei Yang, who is a physical chemist here at Widener University. He's an associate professor of physical chemistry, and he also teaches labs and nursing labs and general chemistry. How you doing, Dr. Yang?
Good. How are you, Aiden?
I'm doing fantastic. Next week's Thanksgiving. We're in that final push. We're talking a little bit before, I feel like this semester specifically, like it feels like things are piling up, but I kind of argue against that. I think everyone just wants to be done with the semester. How you feeling for the end of the semester?
So basically, I have the same feeling as you have. Yeah, at the beginning of the semester, everything was not that bad. But when the semester is going on into the middle of the whole semesters, I think the toll is piling up. Yeah, I think students get kind of exhausted, and at the same time, faculty members also get a little bit exhausted. Yeah, I think most people have the similar feeling that we wish the semester, will be ended as soon as possible, right?
Yeah,
but probably that's the case. Yeah, we only have about 2 or 3 weeks left, right?
Yeah, I think we do. Like we literally have 3 weeks left if you count finals week.
Okay.
I don't even know if I have any finals, honestly, if I think about it now. Maybe one. But do you think you're fully adjusted now? Like, do you think you're fully adjusted online? You think you got it all down, or do you think there's some things to work on?
But I couldn't say 100% adjusted, because there's always something you cannot do online, right? When you do in person, yeah. But I think everybody is trying to learn, what's the best strategy we do for online teaching or for online learning, right? So we are getting better, but we still hope when the whole situation is getting better, we can still go back to at least part of the in-person teaching, right? So yeah, I think the scenario is probably if we do have a hybrid, that will make things much better. For example, right now, testing is a little bit challenging for us, right? Online testing is always basically a little bit out of our control, because we cannot see how students is doing on the other side of the internet. So if we can do testing in person or some worksheet, right, in person, we can answer students' question face to face. That will make the whole things or whole teaching and the learning things much efficient and much better. Yeah.
Yeah, I think it's tough because, students are. I would say about 80% of students are super driven to get the grade. They're not necessarily they get caught up in getting the grade and the numbers versus actually learning the material. So when when they're taking the take-home exams, they get so caught up in getting it right, and looking things up online because they want to be right versus actually looking at the question, actually learning what it is, and it's tough, right? So what do you do?
Yes, because in the short term they want to pass the class, right?
Exactly.
Yeah. Probably some of them know, they are coming here, spend a lot of money, is to learn something, right? It's not just passing those classes. But at the same time, they realize if they cannot pass these classes, they cannot move forward with their program, right? They have to be delayed for one or even for longer period. Yeah, they are struggling. But for us, for professors, we can do our best to educate, our students, right?
Yeah.
What's the true purpose of taking those classes, right? But at the same time, we have to realize, that's not clean cut.
Yeah. So Dr. Yang, I want to hop right into this because I think a lot of people are curious, your background. So you're from China. Where did you grow up, and like where did you grow up, and like what was it like growing up like in China? Like what are the how is it different than growing up like in America? Like what are some of the differences that you see?
Okay, that could be a whole episode of your, yeah. Let's do everything, in short, right?
Yeah.
So, like the United States, China is also a huge country, and Actually, I was born in the capital of China, Beijing. Yeah,
Oh, wow.
yeah. So, yeah, Beijing is also a large city. Yeah. So, Beijing has very long history.
Mm.
If I'm not mistaken, Beijing was established about 3,000 years ago. Yeah, yeah.
You know,
And
I have no clue.
yeah, in the recent history, Beijing has been the capital city for many dynasties.
Mhm.
Yeah,
Yeah.
yes, Qing Dynasty, Ming Dynasty. Yeah, so that means it has a lot of history, right? In Beijing, like Forbidden City, right? That's where the empires, live with their families. Yeah. So right now, that's the most popular, tour place, right, for people from other regions of China or for foreigners. Yeah. And yeah, I was born in Beijing. I feel proud of my identity.
Mm.
And also Beijing uh, wasn't that large city, you know, when I was in high school or in middle school. But in the recent years, just like the whole China, right? Everything is expanding, everything is growing. Yeah. So right now, I think Beijing is the third largest city of China.
Mm.
Yeah, it has about the whole official number is 20 million people.
Oh,
Yeah,
wow.
but the real number I know will be larger than that. Yeah, because
Did you
there's a
say
lot of
Beijing was the third largest? Is
yeah
Hong
third
Kong?
largest. Yes,
Beijing's the third largest. Well,
yeah
I mean, I
third.
assume I assume Hong Kong is bigger.
No, Hong Kong is
Hong Kong's even bigger. Holy,
smaller. Yeah, yeah. Hong
what?
Kong is a smaller city in terms of size, right? That's why
Oh,
if you go to Hong Kong, you feel very crowded because yeah, the
yeah.
size wise, Hong Kong maybe is one third of Beijing. That's why even though they have a less population, but
Yeah.
you feel Hong Kong is kind of a crowded. Yeah.
Mm.
Yeah, but in terms of the population number, yeah, Beijing has more people than Hong Kong. Yeah,
Okay.
so that's my understanding. But what's the differences? Yeah, how many people do we have in Hong Kong? I don't have the exact number. Yeah.
Okay. Well, I want to ask you this too. So you're a physical chemist. So how did your like how did you like get into chemistry? Like was chemistry something that you're always interested in, or is it something that you like kind of developed over time?
Yeah, I think that's very interesting topic. I want to share my experience with you. Yeah.
Yeah, of course. Yeah.
So I look at your basically your bulletin points, right? So yeah, in order for me actually answer this question, so probably I can touch your second topic a little bit
Hmm.
regarding the differences, between China and the United States regarding their education system. Yeah.
Yeah. So
But if you do not have some background regarding that, then probably you'll be a little bit harder to understand why my experience or my relationship with chemistry will behave like this way. Yeah.
yeah, go ahead. Yeah, please.
Yeah. There's some uh, I couldn't say major differences, but there's a lot of differences between China and the US.
Hmm.
So in the US, like you, right? So when you try to decide your career path, normally you will find your interest, your passion, right? So at the end of the day, you are trying to do something you love to do,
Hmm.
right? But not every person will do this way, but most of the people right here trying to develop their career like this way. Yeah. However, in China, I can call this as a bottom up, right? So you find your passion, then you gradually, climb this ladder to the
Hmm.
top. In China, so the way of the education system is about, it's more like top down. Yeah. So normally, when you were in high school, yeah, so your parents or your professor, so basically they will tell you, okay, based on your performance, yeah, you should do this, you should do that, right? Because they think they know better about their students, their children,
Then
than
you
the
do.
children or student themselves, right?
Hmm.
They told us we are more experienced. We were through this process. Yeah, we will make the choice, for you.
Hmm.
So that's one thing, that's different. Another is, uh, at at the time when I, was in high school, the college access at that time is still kind of limited. Even, I'm in Beijing, right? We have a lot of universities, but the admission is still kind of a competitive, right? You have to pass national admission test, and they take the higher grade, the lower grade, will lose the opportunity. So that's why when you decide your major, or when you decide, your career path, probably sometimes people have to do they are good at, not they are love to do, right?
Yeah.
There is a maybe gap, right? For some people, they were lucky, they can be good at something at the same time doing that, but however, for a lot of us, yeah, there's a discrepancy. Yeah. So
So
that's why
were your like parents and like your professors, they were like, you're good at chemistry, you should go do chemistry, and they made you do chemistry?
uh yeah, at that time they were not that specific. Yeah.
Okay.
So we do have a two career paths, we can decide um, at high school. One is natural science, like physics, chemistry,
Hmm.
and even math, yeah, something like that. Another is a
Yeah.
social science
Hmm.
or arts, like accounting or history or something else. Yeah.
Hmm.
So you have to decide which direction you will go, before you go to college, even before you go to college. So at that time, actually we can go back to your, actually, I say there's a analogy I always want to tell people the differences between these two education systems. It's about probably marriage, right? The
Hmm.
analogy is not perfect, but probably right here, it's just like you will date somebody
Hmm.
before you get married with that person. Yeah.
Yeah.
Then you can say, okay, because I love you, then I will marry you, right? But in China, at least at that time, so the education system more like you have to marry somebody
Before
at
you like
sight, then you become to dating that person and become to love that person. Yeah, it's not perfect analogy, but it's kind of similar. Yeah. So
Why is it like that? Is this just a cultural thing? It's been like this for hundreds of years, or?
actually, yeah, part of that is the cultural thing. Yes. So China has a very long history. Yeah.
Hmm.
Even back to 1,000 years ago. Yeah. So most families are kind of authoritarian, things. Right?
Hmm.
So parents has a lot of say in terms about their children's career, even
Hmm.
their marriage. Yeah.
Wow.
Literally their marriage. Yeah. At that time. Yeah. So that's why your parents or your professors or your advisors had a lot of say regarding what kind of a career direction you will follow. Yeah.
Hmm.
So right now, I think things getting better. Yeah. So believe or not, China now the education system become more westernized. Yeah.
Yeah.
It's more like what you are doing here.
Doing
But
here now.
back to 1 or 2 decades ago, something
No.
still like what I just told you.
Yeah, definitely not for sure.
Yeah.
So you were kind of lucky, right? Because you you decided to pursue chemistry or pursue the natural sciences, but did you know you always liked it? So like when you started doing your education, like did you know you liked chemistry, or like was it? Did you kind of get lucky and was like you liked it at the same time, where like you had to go do it, but you also liked it?
Yeah. My relation, okay, I could probably relation is a good word. Yeah, you talk about passion. Yeah,
Hmm.
passion probably is two big words for me. Yeah, my relation with chemistry is complicated. Yeah, as I told you, in China we start learning actually science at very early stage.
Hmm.
So we start to learn physics as the first year of a middle school, and the chemistry at the second year of middle school. Yeah.
You learned physics at the first year in middle school.
Yes.
What the?
Yeah. Of course, it's very introductory, but
Yeah,
we
that's.
learned that concept very earlier.
I
Yeah.
think that's pretty crazy. I think that's pretty cool. Actually, I would have liked to
Yeah.
take physics in middle school.
Yeah.
It's like very conceptual.
Yeah. At the beginning, I like physics, but I also like chemistry a lot because
Hmm.
in chemistry, the professors, when they were in classroom, right, they did a lot of demonstrations, right? So fireworks, gases coming out of a beaker, and make you intrigued, make you excited. So that's why I like chemistry, both chemistry and physics at the beginning. Yeah.
Mhm.
But yeah.
And you're a Husky, right? You're a Husky, right? You got your PhD from UConn.
Yes. Yeah, I'm Husky. Yeah.
So how did you like discover like UConn? Like what made you want to come over here to America to pursue your PhD?
Okay. Yeah. So when I let's say finish my undergraduate study in China, right? So at the time, China become more open to the rest of the world, right? We do see a lot of people, went overseas to get some, higher education. So that's why I also decided at that time, maybe I can, went outside to see what's the differences between um, outside world and the China, right? So that's why, like, what you did, and here you apply a lot of universities. I also apply different universities at the same time,
Mhm.
and I got a couple of offers. Yeah, one of the offers was University of Connecticut. So yeah, of course, one of the key reasons I decided to go UConn is they provide full scholarship, right? At that time, our family was still poor, so we couldn't afford, the whole cost of studying, overseas. So that's why when UConn offered me the whole scholarship, so that's why I say, okay, yeah, I decided to go to UConn for my PhD study. Yeah. So at that time, my study, is related basically related to thermodynamics, right?
Mhm.
We know physical chemistry have a few different components, right? One is physical thermodynamics, another is quantum mechanics, and the third one is statistic thermodynamics. Yeah. So when I was UConn, basically, yeah, my study is related to thermodynamics. So narrowly speaking, is a phase diagram. Yeah. When you go to PhD program, right? So your research will become narrower, right? So you cannot just study everything. Your research program will go deeper and deeper, but
It's like direct,
basically
more specific.
narrower and narrower. Yeah. So that's how we end up with UConn. Yeah.
Yeah. So do you want to? I want to ask you because I bring a lot of guests on here, and then
Yeah.
I bring it like professors, and when I talk to professors, they're like, "Yeah, I was doing organic, I was doing inorganic, but then I was taking physical chemistry, and I was like, oh, physical chemistry wasn't for me." I start laughing. So what is so people that don't know like what is physical chemistry, and then like why do you think it's important for people to know?
Okay. So give me maybe 1 or 2 minutes. Yeah, I want to
Of
go
course, yeah,
back
take your time.
a
Yeah.
few more topics. Yeah, regarding my relationship with physics. No, chemistry. Yeah,
Mhm.
actually, I like chemistry at the beginning, but when I was in high school, when we touched organic chemistry, all right, I was totally devastated. Yeah, yeah. Unlike other professors, yeah, they hate physical chemistry. Yeah, but I end up with teaching physical chemistry because I was totally lost when I was into organic chemistry. Yeah,
Can't
there's
handle mechanisms.
there's too much things you have to memorize. There's a lot of things, you know, which do not follow the sum of rules, right? There's a lot of exceptions. So
Yeah.
make me crazy. Yeah. So that's why at that time I was wondering if I really need to, being a chemist. Yeah. That's why I swing away from chemistry at that time. Yeah. So when I was in college, yeah, my major was materials physics and chemistry, but it's more uh, about physics, less about chemistry. Even though I take all the courses, yeah. So, but when I was in UConn and when I was doing my postdoc research, yeah, I swim back to chemistry a little bit because my research at that time, is more like chemistry. Yeah, that's why I have some new, understanding of what chemistry is. Also, when I did my postdoc research, I had a chance to teach physical chemistry. Yeah, so that's why I say, okay, I gave them a second look. Actually, that's opened the door for me. Yeah, go back to your question. Yeah, so for physical chemistry, right? There's the different branches of chemistry, right? So organic, yes, of course. Maybe you are going to do the organic, right? Yeah.
Love
Don't
organic.
tell, uh, Lloyd, right? So I hate organic. Yeah.
I joke with Dr. Baston. I'm his predecessor. I'm gonna take over the program one day.
Okay. Good. Yeah, we are waiting for you coming back. Yeah.
Yeah.
But yeah. So like, its name, right? Physical chemistry, right? So this name is telling a lot, right? Physical chemistry, I think, is kind of a integrated subject, right? So here you are using mathematical tools and apply physics principles to study the chemical system. You see, all three things, math, physics, and chemistry, are integrated together to do one thing, to learn the property of a chemical system.
Mm.
So I think that's probably where the challenge about physical chemistry is. At the same time, I believe probably that's the beauty, where's the beauty of this topic is about, right? So
Yeah, I think a lot of people are they get turned off by the mathematics of physical chemistry. Because I know like when I was going through it, not that I didn't like it, but it's a lot of integration and derivatives, and I think understanding why integrals and derivatives and why understanding why those things are important versus actually doing the integrals is less important. So, but I think it's cool though when we study like quantum mechanics and thermodynamics, which are two subjects that are within physical chemistry. That's really cool. So
yes, because I think physical chemistry can tell you a whole story about the chemical system, right? So for thermodynamics, it tells you what kind of a bulk property of a given chemical system is, right? Like Gibbs energy, right? Like Gibbs energy can tell you if a chemical reaction or physical change is a spontaneous or not, right? However, on the other hand, yeah, quantum chemistry or quantum mechanics, yeah, will tell you why, the system behave that way from the molecular perspective, right? Just like, I give you a grade at the end of the semester, right? I tell you, Aiden, you got 91 A for the class, right? That's your overall behavior or overall performance. But at the same time, I also give you a detailed analysis, right? I'm telling you, Aiden, all right, the reason why you are doing good is because, you attend every class every week. So you did your homework pretty good. You also, attend our office hour regularly. Yeah. So that's the detailed analysis, right? For
that's
why
cool.
you are behavior like that. Yeah. I think quantum mechanics just something like that, right? So it tells, your audience, your people, why the whole system behave like that way. It's because individual units like molecules, like those electrons, behave something in that way. Then when you put everything together, all right, then that's why the whole system, have that property. Yeah.
What do you think? What do you think? Like, let's say because I have some viewers that don't know anything about physical chemistry. They don't know any. They study humanities or whatever.
Yeah.
What do you think's like one or two things that everyone should know about physical chemistry? Like, so here's some things that you should definitely know.
So it's about the physical chemistry contents, or it's about how we need to learn chemistry. Yeah. What kind of a,
Either way, either one. You can do both if you want. How about one thing that's specific to physical chemistry you think people should know about?
okay. Yeah. So be a little bit more specific. Yeah, as I said, physical chemistry basically covers three different topics, right? One is called thermodynamics. Yeah. especially for engineering students, yeah, you already learn something related to thermodynamics. Yeah, thermodynamics is basically telling people, the bulk property of a system you are looking at, right? And how energy or thermal energy exchange between the system and the surrounding. For example, when you try to design an engine, when you have a chemical reaction, how much energy will be released or will be absorbed by that chemical reaction, right? So that's thermodynamics. Yeah. And on the other hand, the second, actually the most important topic, or I believe that's the most important topic in physics, is quantum chemistry. Yeah, is to study how electrons, or how, should I say, how those small units in the system behave, right? Like what we talk about, is why some solution has a color, right? Why something, um, can emit electrons, right? We call that photoelectric effect, right? So it's because electron is not, like stone, right? They are moving around, right? They are jumping to the higher energy level. They are back to the lower energy level. At that same time, they release energy, right? In terms of electromagnetic waves. So that wave, is somehow falling into the visible region, then it shows colors, right? So basically, it's related, to a lot of things you do see in the real life. Yeah. So it's not just, very, prestigious, theoretical study. It's kind of a down to the earth. Yeah. Don't be afraid of those mass or those, derivatives. Yeah. So if you cannot overcome that, yeah, that's part of the physical chemistry. It's not the whole story, right? So it make you, learn the physical chemistry. What is physical chemistry about? Yeah, if you are really into that, then for your future you can go down this route. If you couldn't, fully, get into this physical chemistry thing, but at least you can learn some, background regarding physical chemistry. Yeah. Yeah.
So just kind of like enlighten our viewers here a little bit. So for the viewers that don't understand how like light works, so electrons exist in a ground state or in an excited state, and when you give electrons energy, they'll move to the excited state. And when that energy is released and it goes back to ground state, it comes off in the form of energy, and some of it is visible light. And so, like when it comes back down to its ground state, it'll release blue light, red light, whatever, and that's how we perceive light. Is that a good statement?
That's how we perceive, color. Yes, something. Yes.
And understanding the thermodynamics of that is a part of physical chemistry. So that's really cool.
Yeah, if I can correct you, understand the quantum mechanics of that is part of the physical chemistry. Yes.
That's really cool.
Yeah.
I kind of want to switch subjects here a little bit.
Okay.
So I want to hop into your research projects. I know you work with John Mason on the MOFs.
Yes.
I wonder if you can enlighten our viewers a little bit on your background of your research and what exactly is your research.
Okay. Yeah. So yeah. So before we're talking about the research, I want to emphasize, yeah. So when people are doing research, there's always a purpose of doing that, right? So you just not do research in order to do research, right? So that's why there's always a larger, scope for why you are doing this research. Yeah. So right now, my research basically focus on metalorganic frameworks. We call that MOFs, right? For different applications. Yeah. One of the application of using MOF is to absorb or capture different gas species. Yeah. Most likely is carbon dioxide and methane. We do know, we are dealing with climate change, right? Regardless if you think that's real or not, but everybody, experiencing the impact of such change, right, in the last several decades, right? Weather get more severe, and natural disasters, get more often, right? So that's the reality. Yeah. So that's why people need to do something about it. Yeah. So we also know fossil fuel is one of the main sources, right, for greenhouse emission. So that's why, when people try to make things better, yeah, they think about what we can do with those greenhouse emission. So you cannot just stop burning fossil fuel at once, right? You
Yeah.
have to gradually transit from one energy sources to another, right?
Mm.
So that's why if we still have to use, fossil fuel, right, most likely for those power plants, then what can we do with those emissions? So that's why people try to find a better or more efficient approach to catch those greenhouses before they are even being emitted to the atmosphere. So one of the candidates, so people are interested to look at, is so-called metal organic frameworks. Yeah. So basically, this kind of material has a two component. One is metal cluster, and another is we call organic linker or organic ligands. Right?
Mm.
It's much longer, you know, uh, part of the component. Right? When you have a metal being connected by those linkers, yeah, it can form one, two, or three-dimensional structure. Yeah. So most of the time, we are more interested into three or two-dimensional structure in terms of a gas capture, because when you have a this structure, right, so the void or the empty space inside those materials, yeah, is compatible with the size of those gas molecules, right? When you have the similar size, so those materials will have the ability of catching those molecules either inside those empty voids or on the surface. So basically, that's what we are trying to do. Yeah, to find out the proper morphs and to capture those carbon dioxide and methane as much as possible, as easy as possible. Of course, we can also tailor those organic frameworks, right, by adding some functional group, right? I know that's organic. Yeah, that's we have to
Love it.
do something about it. Yeah.
So just let me do a little recap here, just so I understand it and the viewers back at home understand. So you have this metal organic framework, which basically means you have this structure that consists of, you know, a metal. Do you guys what kind of metal do you guys use? Do you guys use salt or do you guys use like sodium, potassium, or like
No, we
transition metal?
normally those metal cluster is a transition metal. Right?
Transition metal.
Yeah, so copper, zinc, iron,
Mm.
sometimes titanium. Yeah, so that's because transition metal have a very unique properties. Yeah, there's a lot of electrons around. Yeah, those electrons actually play a critical role in this kind of situation. Yeah,
And
so
those,
normally
so
we do
those,
not use a sodium.
yeah, so those, okay, so the transition metals are then linked together from some organic molecule, whatever you guys use,
Yes.
and it builds like a big structure, and
Yeah, big
within the
structure.
empty spaces of the pockets, you can capture. The idea is that you can capture gas,
Yes.
specifically for your case CO2, but within these empty spaces, you could capture gases.
Yes. For
Is that a
example,
size thing? Is it based on size, or is it other properties like um, like uh, like it's attracted to these these metals? Like are gases attracted to the metals, or is it just a size thing?
both of them are critical. Yes.
Hmm.
So size-wise, you want that uh, that pore, we call that pore. Okay, is compatible with your gas molecules, right? Hydrogen molecules smaller, so you want that pore a little bit smaller. Otherwise, you cannot catch those molecules inside, right? They will escape very easily. Yeah, pore size is one of the critical factors. Yeah, of course. At the same time, yeah. So the interaction, right, between gas molecule and your metal cluster is another key factor for you to capture those molecules, right? If you do have a strong interaction, between the metal cluster and your molecule. Those molecules will stay, right? Will be captured inside. So if you have a very weak interaction between metal cluster and your gas molecule, yeah, your gas molecule will have a higher tendency to escape from those structures, right? That's why you have to look at both at the same time. Yeah.
So where are you right now currently in the research? Are you working on right now synthesizing these MOFs, or are you actually like shooting CO2 through it for capturing?
Yeah. So you once again you're on the points. Actually, we are doing both, right? So
Okay.
we are more focused actually on the property sides, right? We try to tailor those candidates material by adding some function group, right? By looking at what kind of a metal cluster is a good for a different purpose. Then we test their properties. But at the same time, right, synthesis of those metal organic frameworks is another topic people are really interested, because like organic synthesis, right? Yeah, you normally have to use a lot of solvents, right? And hold that at higher temperature for a longer period of time. That's not
Not very
environmental
green.
friendly. Yeah,
It's not
it's
very
not
green.
green. Yeah, not green. Yeah. Then right now we also focus on if we can use a greener synthesize, like using microwave, right? That's what we have to
Yeah,
synthesize the
the
same
microwave.
metal organic frameworks. Yeah, it's faster, and yeah, I think it follows some green chemistry principles here. Yeah.
We love that. We always listen. I always appreciate green chemistry around here. Green chemistry is always welcome here.
Yes.
Well, I think that research is super cool. What have you guys found so far? Like, what have you guys drawn any conclusions yet, or like where are you guys sitting right now?
Yeah, we get some preliminary results. Yeah,
Mm.
in terms of synthesize. Yeah, in the last summer, John Mason, yeah, delivered microwave synthesize over a copper BTC. Yeah, so we found out when we use a microwave synthesize, yeah, the results was faster, right? Normally, by using the traditional solar thermal method, you have to spend probably 8 hours or even longer to get the
Yeah,
products.
right.
Right
Yeah.
here, yeah, we probably just 10 minutes, yeah, we are done with the synthesize.
That's
Yeah,
great.
yeah.
It's really cool. You
So
cut
the
that.
property they are compatible, yeah, in terms of a pore size and the pore volume. Okay, so now we are focusing on probably we need to further tailor those MOFs by adding some function group so that it can absorb more gases of our interests, like carbon dioxide or methane. Yeah, so that's one of the direction. Another direction is that's with stephanos, right? We are trying to use these MOFs to do some glucose absorption. Yeah, yeah, because right now, for diabetes patient, right, they use enzyme-based detection, right? So they use some strips and detect if your sugar, or your glucose is high or not. Yeah, but that's kind of expensive, and it's use a lot of materials. But right now we are trying to see if we can use a MOFs as the sensor of glucose in solutions first, then in your blood next. Yeah.
That's interesting. So people that are diabetic have high glucose, right, in their blood.
Yeah.
So how would the MOFs help that? Like, what would be the purpose of capturing them and just
Yeah.
seeing the concentration of your glucose?
Yeah. So we use ideally speaking, we use a MOF, right, to catch glucose only from your blood, or more sensitive to glucose than other component, right? So if the MOFs can absorb a lot of uh, glucose, it will be connected to the electron devices. Then we can detect the current, right? If a higher concentration of glucose and the higher current, from the reading, then we can tell if your glucose concentration is high or not. Of course, you have to have a very selective, absorption and a
Yeah,
very sensitive absorption, right? You cannot catch everything. You only can catch glucose, and also very sensitive to that.
that's really cool. That's really awesome. Well, you got some groundbreaking stuff going on over there, Dr. Yang. That's really cool.
Hopefully, yeah.
What do you think? What do you think some of like the misconceptions are like about physical chemistry and about yourself?
Okay, yeah. I think about this question a lot last night. Yeah, I don't think there's a lot of misconception about myself.
Mm.
Probably the reason why people uh, wondering about me is because maybe they do not know me very well, right? So yeah, so that's why if they can have a more conversation with me like that, right? I think we will have a more understanding between me and other person, right? Then and I think yeah, that will be beneficial to everybody. Yeah,
Mm.
but right now I think people are pretty busy and normally we do not have a lot of time to communicate. Yeah, so that's why for those audience, all right, if you want to talk to me and we can set up a time and I can share a lot of stories. Yeah, I'm a good cook. We can have a lot of
Which,
uh,
by the way, I do want to talk about it in a little bit. We can. I want to get back to your cooking though. We'll get
okay,
back to that in a little bit
yeah,
though.
but for the physical chemistry, yeah, probably the misconception of chemistry is it's just so hard, right? So it's just so complicated. Even before I started, I feel frustrated. I feel scared. Yeah, that's a lot of misconception. Yeah, but as we know, you have to accept. Yeah, for a regular person, yeah, like myself, yeah, sometimes you cannot be good at everything. Yeah, maybe physical chemistry is one obstacle for your career or for your study, but at least you need to give physical chemistry a fair shot, right? Maybe I borrow this word from Joe Biden. I don't know. But anyway, so you need to open your mind, right? So you need to, let's say, um, be patient when you are learning physical chemistry. Yeah, you need to be, very, strategic, right? Yeah, you need to act earlier, and at the same time, you have to do more practice and
Mm.
more practice and more practice. Yeah, at, at the end of the day, yeah. So your whole career won't be determined by one class, right? Physical chemistry. If you are really good at it, that's perfect. If you are not, at least you know what physical chemistry is and what it can do in the future. When you need to use physical chemistry, you can come back to this topic, right? And do your own study, right?
Mm.
Right here in in our classes, we are not intends to teach everything, let you understand everything. At least our bottom line is to let you know what topic will be covered by this class. In the future, if you really need it, you know where you can get those knowledge, right? So you can come back to physical chemistry in the future if you need it. Yeah. So that's basically about education. Yeah.
Yeah, I think looking back on physical chemistry now, I appreciate like what you did, and I not. It's not that like I don't really care about all the integrals and stuff like that, but understanding like what physical chemistry is, because it's actually pretty applicable, especially for myself. Because I was talking to Dr. Baston, we're doing like within our research, we're synthesizing our product,
Yeah.
and we can't get the product to be pure, and we believe it's because we're the reaction time that we have and the temperature that we have is right at that equilibrium, or is right at the activation energy between the reactant and the product. And so I suggested, I was like, well, if we could just figure out what the activation energy is to react into the product, then we could make reaction conditions to be more pure. And that's physical chemistry. It's
Yes.
looking at its thermodynamic properties. And if we could figure that out, then we wouldn't have this issue. But so I think it's really applicable. And if people shouldn't get so bogged down on learning all the math integrals and stuff like that. It's all about understanding what's happening. That's, I think it's way more important.
That's true. Yeah. Yeah. If you couldn't, do good with those maths, yeah, but at least you need to understand the result at the end, right?
Yeah. What do you think? So, would you say what's some advice you give to like prospective students? Do you kind of give them the same thing, just give them a fair shot, or do you have other things that you would say?
Yeah, I think probably already covered a lot of advice, right? I want to give the prospective students, yeah.
Mm.
So I think one key point regarding physical chemistry, yes, it's different than other subject, right? You need to have that expectation, yeah. So that's why we do have a different directions or branches in chemistry, yeah. Physical chemistry probably is quite different than other things, yeah, because as I said, it uses physics, it uses math a lot, right?
Mm.
So that's the beauty. Also, that's the challenge. Yeah. So yeah, communication is also pretty cool things, right? So in college, right? Yeah, every time when you have anything you struggle with, right? Either physical chemistry or anything, right? So you need to communicate with your professor or your your student peer, right? To see if there's anything they can offer regarding the insight or alternatives, right? Help you to overcome those things. Yeah. For the prospective students, yeah. So try to get in touch with me or other professors as early as possible. If you feel some stress, right? Of course, if you do have a friends, you can also learn from your friends. Yeah.
Yeah, for sure. I think communication transparency is definitely like really key. Because everyone's in the same boat. Like students are in the same boat as you, and professors are humans too. Like they need interaction. Just it's all about transparency and communication. Absolutely, ask when you need help for sure.
Yeah.
All right, so Dr. Yang, as we wrap up here, I want to come back to the cooking because I know you're a really good cook. You've been cooking up a lot of stuff. Before we finished up physical chemistry last spring, Dr. Yang made some dumplings, and he said he would share the recipe. I don't think he ever did. Did you ever share that recipe for your dumplings?
Yeah, I think I didn't. Yeah, even though I made a promise, I didn't, share the recipe. Yeah.
Oh man, can you send me the recipe? Can you send me what to do? I want to make dumplings. And I want to show you. I want to show you what I made.
Okay, that will be great. I don't know, if you can make dumplings at the first time. Yeah, but I can definitely, give you the recipes. Yeah, I can even actually, I took some videos at that time, right? I show you guys a small short videos, but it's not the whole process. I
Yeah.
can shoot a few more videos and for each of the step, and that will probably more beneficial to your practice. Yeah.
Can I
So
please
that's
get the
like
videos?
remote learning, right?
Yeah.
You do have a textbook. You also need to have some videos, right? So I will definitely do this.
Send this to me.
Yeah.
What's
Pretty,
what's next on your list? Like, what are you making next? Like, what are you looking to make?
you mean, let's see. Yeah.
Or what do you
Actually,
want? Like, what do
in
you want?
recent days, I'm making a lot of steam steam bomb.
What are they called?
Steam burn. So basically, it's basically larger dumplings, but it's steamed.
Okay, they're steamed.
Yeah.
That sounds great. I love steamed dumplings.
Okay. Yeah.
Does Chinese food in America live up to real Chinese food over in China?
You know the answer, right? I don't need to answer your question.
Oh,
Yeah.
I'm curious.
So basically, I say 95%, is not living up to our expectation. Yeah.
So if I
Because
walk down to #1 China right now, that's not authentic.
I would say 95% are not
No.
authentic. Yeah. Yeah.
What should I? What Chinese food should I make? Like what's something that you like really love over there that like something that everyone should have?
So one key difference is between very authentic Chinese food and American Chinese food is how to use sauce or how to use sugar, right? So yeah, in authentic Chinese food, unless the main flavor of that dish is sweet, then we can add a lot of sugar, right? If the main flavor is not sweet, then we seldom add any sugar at all. maybe tiny amount. But here, I think a lot of American Chinese food, have been adapted to Americans, right? That's why
salt. There's like no sugar.
Yes. So that's why when you go to Panda Express or any Chinese restaurant, they are now making authentic Chinese food. Some restaurants, you can ask, can you make a real Chinese dish? They say okay, but you have to ask. Otherwise, they just say, or they just make American Chinese food for you.
So let's say, Dr. Yang, let's say you die tomorrow. What are you ordering tonight? Like what would be your last meal? What would you eat?
I don't know. Must be a comfort food, right? Must be a comfort food.
It's got to be comfort food. Yep.
Yeah. So I think in China, comfort food could be dumplings or could be noodles.
Dumplings and noodles. Any specific dumplings or noodles? Like should you use chicken, pork, lo mein? And what would you do?
Say it again.
Like would you use chicken, pork? What would you put in your dumpling? Both?
You can normally you do not have a both. You can have a, let's say, pork. The very typical dumpling filling is ground pork. There's a Chinese cabbage plus some mushroom. Okay.
Ooh.
Yeah.
I love mushrooms.
Yeah, mushroom. Yeah, and for you can also use ground beef. So when you use a ground beef, our typical recipe is ground beef and celeries and also some green pepper. So really chicken, chicken normally is too lean, right? There's no fat, so it won't make dumplings delicious. That's why even you use a ground chicken, you still need to add some other meat, right? So sometimes you can add a little pork, but chicken normally we make meatballs using ground chicken.
Chicken meatballs. Oh man.
Yes.
Well, Dr. Yang, I want to thank you so much for hopping on the podcast. I appreciate you coming on and talking about your MOFs and your Chinese food.
Okay. Yeah. I think.
And your physical chemistry, of course, but
Cool. That's cool. Yeah, because I think today's episode probably is the longest one, right?
I think this is definitely, we've been on here for a while. I don't know. We'll see. Dr. Bob was like 50 minutes. I think you'll be like 50 minutes.
I think I want to break his record.
You want to break his record?
I want to beat him. Yeah.
Well, Dr. Yang, you're always a pleasure to talk to.
Okay.
Send me those dumpling recipes. I'm going to make them.
Okay. I think the next maybe episode when we meet again, so you need to show me your dumplings, right?
Next episode that you're on, I'll show you my dumplings. And you'll show me your MOFs.
Something else. Yeah.
You're going to show me your MOFs.
Okay. Yeah. Awesome.
All right, Dr. Yang.
Yeah.
If you guys like the content, please like and subscribe. But that's been episode 11. Thank you, everyone.
Unless I stuck by you.